Okay, now the second questions in graph of simple harmonic motion. The graph above shows the variation of the potential energy U with displacement x of a body of mass 0.5 kilogram in a simple harmonic motion. What is the amplitude, the angular frequency, and the maximum velocity of the simple harmonic motion? Okay, so this is a energy with displacement graph. Okay, in fact, a potential energy with displacement graph, right? So what information given is, of course, you must take note. It has mass given. It has mass given. Okay, in fact, I write down here already. Okay, there's a mass. Okay. So what information can we extract from the graph? This is the energy versus displacement graph. First of all, okay, this one is the maximum potential energy. Maximum potential energy, which is when it is maximum, it is equal to the total energy. When the formula for total energy is half m omega square amplitude square. And then the next one is the amplitude. We can get from the amplitude. This is actually the maximum displacement. When displacement is maximum, it is the amplitude. Okay, and this is the negative amplitude. Okay, so and another thing you must take note is the unit. This is joule. Okay, so no need to convert. It's already in SI unit, and this is in meter. This is very important. All this thing. This meter means the unit, the amplitude is in meter. Okay. Sometimes it can be cm. You know, it can be cm, it can be mm. Who knows? It got give other unit. So be careful with the unit. Okay. This one in meter. So the amplitude is in meter. Good. The unit, this one is kilogram. Okay. Good. Kilo SI unit. No need to change. So what is the amplitude? Okay, things he asked is amplitude. Okay, thing he asked is amplitude. The angular frequency is omega. Okay, omega. The maximum velocity is V maximum. Okay, so what's the amplitude? We already have it. 1.5 meter. Not centimeter. Meter. So the answer is 1.5 meter. Very simple. Okay, what's the angular frequency? Angular frequency, omega. So how to find omega? Omega is somewhere around here. We have omega here. We have omega here, you see? Omega is here. So omega is hiding inside the maximum potential energy. Hiding inside. So we need the 8 joule. Okay, we need the 8 joule. So in fact, this is the U maximum equal to 8 joule, which is the total energy. So the formula for the total energy, just now I already said, is half m omega square A square. Okay? So just write it down. Yeah. Okay? Yeah. So half m omega square amplitude square is equal to 8 joule. Okay? Because 8 joule is the U maximum, is total energy, half m omega square A square. Alright? Now, do you have the amplitude? Yes. 1.5 meter. Do you have the mass? Yes. 0.5 kilogram. We can find omega easily. So simple. Already in SI unit. So we need the omega. I need the omega. Come on. I need the omega. This is 1.5. Okay. Give me the omega. So what's the omega? What's the omega? What's the omega? Yeah, 3.77 radian per second. That's the omega. Okay, that's the omega. Now, the unit is radian per second. Okay, now, what's the final question? What is the maximum velocity? Maximum velocity? The formula for maximum velocity is A omega. A omega. Okay, maximum velocity is A omega. So it is amplitude. We have amplitude. Yes. We have omega. Yes. Very simple questions. Okay, 1.5 already in SI unit meter. The omega is also in second. So or in SI unit, nothing to worry. Okay, so just multiply A omega. So what do we get? It is 5.655 meter per second. The unit is meter per second. The velocity is meter per second. Okay, is that correct? Yeah, 5.66, 5.5655, same, yeah? Okay, so that's it, how we do it. Yeah, very easy. So you just, what important here is you just check the maximum value. This is the amplitude. Yeah, this is amplitude, and this is the maximum is the total energy, which is half m omega square a square. From there you can find anything you want, like the omega. And also be careful with the unit. Meter sometimes can be cm, can be mm, joule lah. Okay. Another thing, sometimes you also can use this value. Yeah, sometimes you also can use this value. This you see it cross at here. The energy at here is 4 joule. So equivalent to this displacement here. You see. So we can say the energy. Yeah, something we can say from here. The energy is 4 joule. So we can use the formula for energy is half m omega square x square. That's the energy for potential energy. That's a because we know the potential energy is half kx square. We know the formula for potential energy is half kx square, and k itself is m omega square. So that's why half m omega square x square. You know this is the elastic potential energy formula. Elastic potential energy formula. Yeah. Anyway, this potential energy is equal to 4 joule, and we know the displacement at this point is 1 meter. So this x here we can substitute with 1 meter. Understand that? The mass is 0.5, and the omega is 3.77. So we can use this formula also. Let's say if questions B, we want to find omega, I think we can use this formula also. Okay, you should get the same answer. You will get the omega also equal to 3.77. All right. Mass, you just substitute mass with 0.5 kilogram. You do yourself. Try out and see. Is the omega also equal to 3.77? Okay, I bet you will get the same answer. Okay, because it crossed at the 4 joule and also 1 meter displacement. Okay, so I hope you enjoy the videos. Okay, there are upcoming videos. Stay tuned for it. Thank you. Bye.